Hello everyone! Welcome back to AI Foundation Learning, your go-to channel for all things artificial intelligence and machine learning. If you're new here, don't forget to hit that subscribe button and click the bell icon so you never miss an update. Today, we're diving into a fascinating and crucial topic, hallucination in large language models. So let's get started. First things first, what exactly do we mean by hallucination in the context of large language models, or LLMs? In AI, hallucination refers to instances where a language model generates information that is not based on the input data or real-world facts. Essentially, the model makes up content that seems plausible but is actually incorrect or nonsensical. For example, if you ask a language model about a historical event and it provides details that never happened, that's a hallucination. It's a critical issue because it can lead to misinformation, especially in applications like chatbots, content generation, and even medical advice. So why do these hallucinations occur? There are a few key reasons. 1. Training data quality. LLMs are trained on vast data sets collected from the internet, which contain both accurate and inaccurate information. If the model encounters incorrect data during training, it can learn and reproduce those errors. 2. Model complexity. The complexity of these models allows them to generate highly plausible text. However, this same complexity can lead to overfitting or the creation of patterns that don't exist in the real world. 3. Human-like creativity. Language models are designed to mimic human language, including our ability to be creative. Sometimes this creativity can go too far, leading to the generation of entirely new but incorrect information. These factors combined can result in language models producing hallucinations, which can be problematic in many applications. Let's take a look at some real-world examples of hallucination in LLMs. 1. Chatbots. Customer service chatbots sometimes generate incorrect information about company policies or product details. For instance, a chatbot might invent a non-existent feature of a product when asked a specific question. 2. Content generation. Tools like AI writing assistants can occasionally produce fictitious facts or quotes. Imagine an AI writing a blog post that includes historical facts that are entirely fabricated. 3. Medical advice. In healthcare, AI models used for diagnostic assistance can sometimes suggest non-existent medical conditions or incorrect treatments based on hallucinated information. These examples highlight the importance of addressing and mitigating hallucination in LLM applications. So, how can we mitigate hallucination in LLMs? Here are some strategies. First, ensuring high-quality, curated datasets can significantly reduce the likelihood of hallucinations. This means filtering out unreliable sources and focusing on verified information. Next, implementing post-processing checks to verify the factual accuracy of the generated text can help catch and correct hallucinated content. Then, incorporating user feedback mechanisms allows models to learn from their mistakes and improve over time. Lastly, researchers are continuously working on developing new architectures and training techniques that reduce the propensity for hallucination. This includes techniques like reinforcement learning from human feedback, or RLHF. By employing these strategies, we can make significant strides in mitigating hallucinations. Beyond the basic strategies, there are advanced techniques and frameworks being developed to tackle hallucination in LLMs more effectively. 1. Integrating fact-checking algorithms within the LLM pipeline can help verify the accuracy of generated content. These models cross-reference the output with reliable databases and flag potential inaccuracies. 2. Providing additional context during the model's training and inference phases can help reduce hallucination. This involves enriching the input data with more detailed and relevant information to guide the model's output. 3. Carefully designing prompts to guide the model towards generating accurate and relevant responses. This can include explicitly asking the model to verify its output or to cite sources. 4. Combining LLMs with other AI systems like knowledge graphs or rule-based systems can provide a more robust framework for generating accurate content. The LLM generates the initial text, and the supplementary systems validate and refine it. These advanced techniques are at the cutting edge of AI research and are showing promising results in reducing hallucination in LLMs. Looking ahead, there are exciting trends and innovations that aim to further address the issue of hallucination in LLMs. 1. This technique involves training models across multiple decentralized devices while maintaining data privacy. By leveraging diverse datasets, federated learning can improve model accuracy and reduce hallucination. 2. XAI focuses on making AI systems more transparent and interpretable. By understanding how and why models generate certain outputs, we can better identify and correct hallucinations. 3. Developing models that can learn and adapt over time, continuously updating their knowledge base with accurate information while minimizing the risk of forgetting previously learned facts. 4. Involving human experts in the training and validation process to provide real-time corrections and feedback. This collaborative approach can significantly enhance the model's reliability. These future trends hold great potential for creating more reliable and trustworthy AI systems that minimize the risk of hallucination. To wrap up, hallucination in large language models is a critical issue that can lead to misinformation and other challenges. However, by understanding why it happens and employing various mitigation strategies, we can significantly reduce its impact. From improving training data to advanced techniques like fact-checking models and hybrid systems, the AI community is making great strides in tackling this problem. As we look to the future, innovations like federated learning, explainable AI, and human-in-the-loop approaches offer exciting possibilities for creating more accurate and reliable AI models. Thank you for joining us on this deep dive into hallucination in LLMs. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon to stay updated with our latest content. And as always, feel free to leave your questions and comments below. We'd love to hear from you. Until next time, keep learning and exploring the world of AI.